Okay everyone, so this is Pre-Calculus 11 and we're talking about the Complex Algebra booklet, part 2. This one gets into the heavy working of the booklet and gives you some insight into some of the questions, how to proceed with the booklet, etc., etc. Of course, the key is attached for your for your learning opportunity to see how things go. So, but don't just fill in the answers because that doesn't help you learn. Just saying. Okay, so let's have a look at some of the questions that we've got. If you turn to page 1, section 1, you've got it starts off with basic absolute value and it just builds little by little. I mean, you've been in my class all year. You know how these booklets work. We start off with simple stuff. Can you find the patterns? And then can you start acting creatively on the patterns that you know and see? And of course, as always, if you find other ways to solve these questions other than what I've shown you, totally fine, right? That's awesome when you do that, right? Find those things if you can. They become your property, your intellectual property, or I guess you could call it your intellectual capital. So yeah, we're building your intellectual capital when we do this stuff. Okay, so question number 1, right? Section 1, question number 7, and question number 3. They're kind of very similar. One has the absolute value on the outside, and then one has the number on the outside. So in the first one, we set it up, we split it into its two equations, right? Split this up into x plus 1 equals 6, and x plus 1 is equal to negative 6. Right? One for the positive and one for the negative. So minus 1, x is equal to 5. Minus 1, x is equal to negative 7. Okay, and what does that match up with? That's letter A, right? That would be letter A. So number 3, bada bing, bada boom, letter A. Okay, so number 7, we have to isolate the absolute value first. So now here we minus the 1 first. So minus 1, x is equal to 5. Absolute value of x is equal to 5, and then we split it into two parts. X is equal to 5, and x is equal to negative 5. Right? There we go. Looks like that. And which one is that? That looks like letter F. Boom. Right, so you can check your answers in the key. They are there. And, just try to get faster at it, right? There's some very simple things that you can train your mind to look for as you go through these questions. And that's really why these questions are there, to help improve the speed of your thinking on these types of questions. And just your speed of thinking overall. Okay, so let's make our way down that booklet and let's go through some of the harder questions. Alright, so let's go down to section 3 on page 1 and let's have a look at questions number 1 and 2. They're almost identical, except that one is equal to positive 2x and the other question has it equal to negative 2x. And we solved a problem like this in the last lesson, part 1 of Complex Algebra 1. And so if you're not quite sure on the full policy on how to manage that, you might want to go back to that video, and it's in the first half of it for sure, probably near the middle, in and around there. So anyways, let's solve this guy here. Remember, we have to split these guys into two separate equations, so let's do it for both. Okay everybody, so in the first question we split it up, one for the positive 2x and then one for the negative 2x. No problem, we can solve those equations pretty easy. And then over here we do the same thing, but remember when I split it for the positive, it's equaling positive negative 2x, right? I'm not changing what the equation looks like. And then when I split it over here for the negative one, I'm making it negative 2x. I'm putting a negative on that, so really the negatives cancel out. And what winds up happening is, we get two almost identical equations on both sides, right? On this side I've got x equals 2x, or x plus 3 equals 2x, and on this side I get x plus 3 equals 2x. And in the middle, x plus 3 is equal to negative 2x on both of them. So we should get the same answers for both. But remember, we're talking about extraneous values now. So which one will work and which one won't work? Okay, let's have a look. Okay, so I've solved them here, and they're pretty easy to solve once you've split them up into the two parts. And I got x is equal to 3, which when I check it winds up being good. And then this guy over here, x is equal to -1, when I check that, it's not good, it's bad. And I will go through the check for that one so you can see it in a moment. But on the other side, right, I get the same two answers because the questions were basically the same two answers. I got x is equal to -1, that's the same as this guy over here, but on this question, this is the good one. And then further along, I get x equals 3, which is the same as that one, but over here it was good, and over here it's bad. So what's the only difference in the two equations? The only difference in the two equations at the start? Well, one is -2x, and one is +2x. So I'll show the checks for the bad ones so that you can see. And then we'll talk about, how can we see this more closely or more quickly if we know a few little bits of theory. Okay, so when we plug it in over here, right, -1, and I bring it down, I plug everything in, I wind up getting the absolute value of 2 is equal to -2. And remember, absolute values make everything positive, right, if you remember the theory on that. So that's not right. Absolute value of 2 is +2, not -2. But our algebra says, well, this one works. No, it doesn't. Okay, and then over on the other side, we get the same situation. If I plug this guy in, right, I get the absolute value of 3 plus 3, which is 6. And then I get -2 times 3, which is -6. I get an absolute value equaling a negative number again. Can't do it. So that's one of the things that you can look for really quickly is the number that you get, will it make the absolute value negative, equal a negative? And if so, you don't have to go through all the checking hassle that we've got going on here. Because really I just did it for the wrong ones. The right ones work just fine, and you'd have to check those too. So, you could look and say, okay, well over here, x is equal to 3. So if I go up here and I plug in x equals 3, am I going to get an absolute value equal to positive? Yeah, I'm going to get equal to 6. You can check it out. 3 plus 3 is 6. 2 times 3 is 6. No problem. Same thing down here, right? If this -1, if I plug it in over here, I get -2 times -1. The negatives cancel, right? And that's going to be fine. So that's one of the quick ways to look to see whether your question will give you an extraneous value, is to see whether this part of it becomes negative. Like does the absolute value give you a negative result when you plug in the number? Well, if you have two negatives, that'll cancel out. If you have a negative and a positive, yeah, then you're in trouble, as we see here. So that's one of the ways to quickly check to see if you got an extraneous value or not. And that's probably the easiest way to do it. Okay, one more with the absolute values. I'll do the very, very last question on the first page, so page 1, section 4, number 4, and it has the absolute value of x squared plus 5x equals 6. And, if you didn't have a clue how to start this, you probably just, want to cry maybe or something. So here, we do know how to do it. So let's be smart, let's be awesome, let's do it. We have to remember absolute values, we've got to split it into two groups. One for the +6 and then one for the -6, because if we get it equal to -6, poof, it becomes positive because of the absolute value. Okay, so let's write out the equations. Yeah, they're quadratic equations. You got to solve them with the brackets and the factoring and all that, but it's not too hard. Okay, so there's the solutions for you right there for the positive one, right? You got to -6 to both sides and factor, and then figure out what makes each of those brackets equal to 0. So I get -6 and +1. And then for the other one, I do the same job, but the factoring is a little bit different, and I get -3 and +2. That's not right. It should be that. Yeah, there, that's better. Okay, so, no, that's not even right. Here you go. Now it's right. Bada bing, bada boom. Okay, there you go. So these are my two answers. Do I need to check for extraneous? Do I have to worry about there being an absolute value that gives me a negative number? And the answer is no, we don't. If you look up at the top, right? Oops. If you look up at the top here I have an absolute value of whatever, like, so it's kind of complex in there, but so what? It equals a positive number. So I don't have to worry about whether I'm going to get an absolute value equaling a negative. It says that this guy is always equal to positive 6, positive. So I don't have to worry about it coming out as a negative on this side. And so that means that all four of those numbers are good. They're that you won't have any extraneous values in that. You can check them if you want, but you take my word for it, they're all fine. Okay, so let's go on to the next page that talks about square roots, and then I'll help you kind of work your way through the sections near the end of the booklet. Okay, so page 2, section 1 is kind of practice, the stuff that we did last video. So section 2, 3, 4 on that page, plus section 1 on the next page, they're all linked together. You know, I like to do that every once in a while with questions where, you know, if you have a lot of steps, I get you to do it kind of assembly line style. So you can do them assembly line style, or you can do them individually all the way through each section. It's up to you. And those of you who've had me all year know you can go either way on that. So let's have a look at section 2, 3, 4, and section 1 on the other one. They're all linked, so the question from section 2 will help you get the answer for section 3, will help you get the answer for section 4, will help you get the answer for the next section. That's what I mean when they're linked. Okay, so let's have a look at the very first question. Alright, so in section 2, what they've got there's the question, and all they ask you to do is to isolate the the square root bracket. So that's fine. We just have to move that x to the other side. Regular grade 9 algebra. Right, so minus x to both sides. You get square root of 2x plus 8 equals x. Big deal. So now in the next section, that becomes the first question of the next section. And how do we turn that into a quadratic equation? Okay, so I square both sides and then organize everything onto the x squared, where, you know, make x squared positive. So, and then I rewrote it to make it look a little bit nicer. But there you go, and I think that's letter H. And so letter H becomes the start of the next section, section 4. Okay, so you have to factor it, and then you remember, okay, what makes each of the brackets equal to 0? So 4, right? The opposite of the numbers. And then negative 2, those are my two answers, and that's letter G. Okay, so if you turn over the page and you go to the top question, we're basically starting from scratch again, right? This question up here, question 1, section 2, page 2, is the same as question 1, page 3, section 1, right? So we know the process to go through and get the answers. We did it in steps, right? Kind of assembly line style. So we know what the answers are. The answers are 4 and negative 2. So I don't even have to work. I just have to follow the path of the answers that I gave going down. Of course, you could solve it normally if you like, but your answers are 4 and negative 2. Okay, so letter A, right? And so after you've completed all 8 of them, all the way through both those pages, I got a little question that says, okay, well, the above answers are not totally correct. Why are they not totally correct? It's the extraneous value situation. These questions will have extraneous value problems or details to sort out. And they ask you to circle the answers that are incorrect. So in order to, I mean, are you saying you have to check them all? No, I'm not saying I have to check them all. But you should know what to look for. And again, it has to do with the negatives, right? Watch where you get different types of negatives. Remember, square roots can't equal negative numbers, at least not without complex or imaginary numbers, which you're not technically supposed to know about. But if I wind up getting a negative square root, then yeah, I can't have that. So that's what you need to look for. And in this case, this guy down here is going to give us an extraneous value. Why? Because when I plug it back into the original equation, it's not going to work. I'm going to get a square root equaling a negative number. Can't do it. So let me just go through the check over here on this side, just so you can see the check of the bad one. And that's what you need to look for. And sometimes it's the negative answer that's wrong, and sometimes it's the positive answer that's wrong. Now, that's not the only situation that you need to watch out for, and I ask you to think about some true or false questions a little bit further down to get you to really, put your mind deeply into the idea of an extraneous value and when things will work and when things won't. So you have to remember, when are things allowed to be negative and when are things not allowed to be negative. And that's really the key to being able to deal with extraneous values in a fast and quick way. So let's just do the check so you can see that I'm not joking. So there's the work for the check, right? When I go back to my original equation and I check it, and there you see it. Now, I don't know, it probably took me about 15-20 seconds to do that. But you know how I said, you always have to go back to the original? Well, that's true, but you can shortcut it. And where things go wrong with square roots and absolute values is when you're trying to deal with the square root bracket. So at the stage where you're squaring both sides, you can still sub it in. So here, I minus x to both sides, and then I got that answer, with all those brackets there. And then I squared them to get this part down here. Well, I could plug it back into this part up here without the squared parts. And it would still illustrate the question a lot easier. So the errors occur when you try to get rid of the square root bracket or the absolute value bracket. That's where you see the errors happen. Those bugs or glitches I was talking about, that's where they occur in the process. So anything before that process, you can plug the question into, and it's a lot easier. So let's just see that. So you can see it's a lot quicker of a test. Okay, so I'm plugging it into this section here because this is before I've squared both sides. I kind of erased the squaring of that in the brackets. If you go back a few seconds, you'll see I had brackets there. I took them off to show you, I just minused x to both sides from the top equation. This is what I got. You can plug it in here, and you'll see, right, that it doesn't work out. So, you're looking for, well, does my square root answer, does the answer part here give me a negative value, equal a negative? And if it does, you can't have that, right? That's an extraneous value. No solution for that particular answer. So that's why you're dealing with that. And that's one of the quick ways to check. Does that happen? No, you're fine. Does it happen? Yes. Extraneous value. Quick decision. You don't have to go through the entire check in order to be able to find what those will be like. So I give you some practice and some things to think about on that. Okay, so we'll have a look at questions number 1 and question number 7 from the next page, page 4, the one that's titled, What is the Advantage of Having Nuclear Physics? So just look at page 1, and the questions are a little bit different, not too much really, and they get into some of the nuts and bolts of the higher end type of questions that you'll need to look for. So question number 1, I got the square root of x over 5, and then plus 4 equals 14. So, as always, isolate the square root first, minus 4 to both sides. Okay, so square root of x over 5 is equal to 10. How do you cancel out a square root? Square both sides. Okay, so x over 5 is equal to 100, and then you gotta times the 5 off the, x is divided by 5, so the opposite of divide is to times both sides by 5. X is equal to 500. Okay, so those are the letters AN that correspond with the code that you have to break at the bottom. So in slot 1, both slots you put the letters AN. Okay, so let's have a look at the next question. Question number 7 says that, okay, well I got the square root of this equals the square root of that. Well, are the square roots isolated on each side? Yep. So we could square both sides, and if we do that, both square roots cancel. Very nice. Okay, the questions don't come much easier than that now, right? It's just good old-fashioned algebra from grade 9. Get her done. Okay, so both the square roots cancel out. Do the algebra, move the d's to the left, and the d's to the right, and the the numbers to the left. 5d equals 30, d equals 6, corresponds to the letter IT. So in slot 7, down the bottom what the code is, you put the letters IT. So let's have a look at one from the third column. Those are pretty tricky. And yeah, I'll look at number 12, I think, is the one I want to do with you guys. Because that's a real challenge. Those last 5 of them are pretty tough. Okay, so there's the question. And, okay, so is the square root isolated on one side? Yeah, it is. So I have to square. But this is very tricky, right? If you don't square this properly, if you don't understand the nature of what algebra is talking about, it's going to go wrong for you. You have to square both sides. Yeah, it's no problem. No, it's a problem. Watch out, okay? I'll show you where people make mistakes. Which one is right? If I square both sides, do I get x squared plus 2 squared? Like I square both of these numbers, so x squared, I guess that's what, plus 4. Or does it work out like this? Or are those the same? I'll tell you right now, no. No. Because when you square both sides, you write it like that, and that means I have to multiply those 2 brackets together. Kind of like FOIL. See how it works out. Alright, that's that. Which is not x squared plus 4, right? You're going to have to FOIL that. Okay, that's x squared plus 4x plus 4, not just x squared plus 4. Okay, so that's a quadratic. You have to make it equal to 0. It's a bit of a pain to solve, so let's see if you can do it. So that's what the quadratic looks like when it's ready to factor. Alright, there's the factored solution, right? 7 times 2 gets you 14, 7 minus 2 gets you 5. So those are my answers. And do we see extraneous values? Yeah, we do. Which one is it? Well, it's the negative 7. Here's how you can quickly check. You want to look to see whether this square root is going to give you a negative on the other side of the equation. So if I choose 2, right, 2 plus 2 is 4, that's not negative, so that should be okay. You can even do it in your head. 8 minus 2 is 16, square root of 16 is 4. So yeah, that's okay. 4 equals 4. But over here with the 7, right, if I put in a negative 7 plus 2, I get negative 5 on that side. And you can't have square roots give you negative numbers. So, automatically, that guy doesn't work. I'll do the check to show you. Okay, so I plug it into the original equation, and there's the work for it over here. A negative 7 plus 2 is equal to 18 double minus, or really plus, remember. So you work that out, negative 5 is equal to the square root of 25. Negative 5 is equal to 5. Nope. So that's why this guy over here is an extraneous value. The only real answer is 2. And so when you're looking for it on the answer section, that's letters Ki, and that goes in the slot number 2, right? Both those letters. And eventually you get the answer to what is the advantage of having nuclear physics. See what kind of joke that is. I know the jokes are pretty bad at times. Okay, on the last page, question number 2 is a little bit tricky, and you like, I got 2 absolute value questions in the same thing on the same side. How do you isolate that? You can't isolate that. How do you isolate that? So how you isolate it is if you notice some very cheeky things. This absolute value bracket is the same as that absolute value bracket. And when that happens, and there's another question similar to that, question 5. Question 5 is similar to that. Because these are the same, we can treat them like terms. It's a fancy algebra technique, and it's not something I'll ask you to know for any kind of test or anything like that. But you can treat them like terms. So you can gather the coefficients. 3x, or 3 variable plus 1 variable, right? You can gather them together. So this works like this. Those work together, the coefficients join together. So 3 plus 1 gets you 4, and then you keep the absolute value bracket the same because they're identical. And then, well, now this shouldn't be too hard of a problem for you to solve. So I'm not going to solve it for you, but I'll help you get over that one little trick. And like I said, this also happens for question number 5. Same trick. Okay, where you join them up kind of using a gathering like terms technique. There's a couple other questions that involve compound, like combining them together, and I'm not going to show you those because I want to see if you have the creativity to solve them. The answers are there in the key, so let me see your creativity. See what you can do with some of these questions. Okay, so that's it for now, guys. Take care, and next time I talk to you, we'll be dealing with the next booklet. Okay, bye.